Right, so I'm really excited to introduce the first speaker. And so I'm going to give some context on them. I actually think the best way to do this is just to read their Wikipedia, because there's so many things they've done. And I don't think I know anyone else who's had such a big impact on computer science in a production setting as Chris Lattner. For context, he made LLVM and Clang. Let me simplify that. If you use C and C++, this is like the primary front end that it goes through in compilation. Like C and C++, a lot of stuff's built with that, right? He also literally made Swift, the programming language, like the ones that millions of people use. He ran the dev tools, like the whole motion at Apple. And so it's like virtually impossible to write software that hasn't been impacted by this guy. And so incredible to have him here. Now he's the CEO of Modular. He's completely changing the ML stack to better support GenAI-native inference solutions. And given how much of the stack he's able to have a big impact on, I can't think of a better way to have it explained than by him directly on how he's changing the game. So thank you so much, Chris Lattner, and it's just delighted to have you here. Big fan.
Awesome, thank you. You're too kind. I like to build things. That's what I'm about. So I'm going to be here to talk about Max. We're at a very exciting time at Modular. A lot of things are changing. A lot of things are coming together. And so I'm very, very, very happy to get to talk about some of this. So GenAI is a thing. We know what this is. It's gone from some amazing early demos to a lot of proofs of concept. And now people are thinking about how do we actually not just deploy this thing, but maintain it over the years to come. And so this is actually surprisingly difficult. Getting a GenAI thing in production is actually, requires this weird mishmash of different technologies. And these technologies have been built very rapidly across the course of many different years. None of them know what each other is. They're all kind of fragmented. They kind of work in the golden path, but they break and fall apart when you get off of it. And it sort of kind of works, but it doesn't feel good. Well, why do we matter? Well, it causes suffering. I don't know all the suffering that you felt. I don't know who here loves figuring out CUDA versioning or getting like AMD to talk to PyTorch. This is not good. This is not the way that software should be. So what are we trying to do? We're trying to fix some of this. We're trying to build and do a fundamental rethink of this platform, really think about GPUs as a first-class citizen, not as an aggregation of different things that got built by researchers over the course of many, many years, but actually think about this as a DevTools platform. And so before I get into this, people always ask me, okay, you're doing a GenAI inference thing. There's like a million of those. So before I tell you what we're doing, let me tell you how we're different. So first of all, yes, you can program GPUs. We do that without CUDA. So we do not use NVIDIA's Matmos. We do not use TensorRT. We do not use any of that stuff, which is a huge step forward. And oh, by the way, it's really hard. But this allows us to get portability and a bunch of other benefits out of this. Second is we care about usability. So many things coming from hardware developers, for example, they care about speeds and feeds and numbers. And yeah, you can walk across broken glass to get to that outcome. We actually care about making it easy and feel good. And that's quite different from today's infrastructure. And third, we care about hardware. And you're talking about open extensibility of hardware and novel invention. It's a golden age for innovation in hardware. And so what we need to unify the hardware innovators with the software developers and make it so people don't have to rewrite all of their code to get onto some new chip. So today I'll talk about two different things. I'm going to try to crush a lot into a small amount of time so that we can have questions at the end. First, I'll be talking about the platform. And the platform is really targeted to people who are advanced developers who are building models, writing low-level code like GPU kernels and things like this, and really inventing new pipelines and new kinds of technologies. And then we'll talk about a GenAI solution, which is a thing built on top of that, which allows people that are more AI engineers to be able to go use this fancy deep technology. And so starting with this platform, well, how does it work? Well, first you have to dig into what is a modern GenAI pipeline. Right? And this is very different than back when I got involved and we were talking about things like Resonant 50 and Inception v3. Today, all this got way more complicated because the expense and the complexity and things like this and the models got more sophisticated. And so today you have to care about preprocessing, like tokenization. Scheduling multiple different incoming requests into a server is really complicated, and there's all these fancy continuous batching and radix encoding, like all this stuff that's going on that's really complicated. You've then got the GPU compute itself, and so a lot of high-performance kernels and flash attention and all this good stuff, which is now integrated with KV cache optimizations, tons of complexity, and then of course you've got networking, post-processing, decoding, and all this kind of stuff. Well, today, this is a gigantic mishmash, right? Because performance is essential. That's why we're using GPUs. And so we end up getting things like Rust and C++ and CUDA and obviously a lot of Python, which we actually like, but it's not fast enough. And there's like all these problems that come with this and drive this fragmentation. So what we're doing is we're saying, let's rethink this. First principles. Let's build a good thing from the bottom up. And this takes a lot of time and investment. But we think that it's worth it to actually get to a better outcome. And so in this platform, we have two things. We have a new AI framework that I'll talk about, and we have Mojo, which is a programming language. So when you look at Max, and you're saying, well, how do I go build this thing? Like, what we're really doing is we're saying, take all of this complexity and smash it down into something simple. Simple, consistent, that composes, that's orthogonal, that actually scales, because we want people to be able to understand this, not just have to build on top of it and hope it doesn't break. So if you dive in, again, just going to some code, it's really simple. Like you can create a simple pipeline. This is overly simple with just like a ReLU and a mapmul, but you can actually build transformer blocks. You can build all these different things. We provide a bunch of the simple stuff out of the box, as well as all the common models and things like that. But if you want to build a pipeline and build a model, you get this similar PyTorch kind of API. Now it's cool because underneath this is a very powerful compiler. And so you get automatic kernel fusion, you get a bunch of memory planning and fancy stuff for free, so you get good performance, even though the API can stay simple. This is a whole platform, talking to lots of different GPUs. Today, depending on what you're doing, you want to actually have full control over what's in the memory, what like the new KV cache optimization of the day, this kind of stuff, and so we give full access to this. And the thing about this is it's all fully portable. This isn't like tied to CUDA or anything like that. For those who care about programmability, you can go further and write actual code that needs to be fast. And so we have Mojo. Mojo is a programming language. First principles, rethink, full stack programming language, member of the Python family, designed to be fast. And so don't have time to dive into how and why, but it's faster than things like Rust, for example, on CPU. So this is not like a slightly better Python. This is first principles, best thing that can run on any accelerator and fully expose the power of the hardware. That said, easy to use, right? And so it's a member of the Python family. You can build on the technologies and the skills and the muscle memory that you have, and this is good. We have a nice community that's growing and a lot of cool stuff happening. There's tons of stuff going on in this category. Well, why is this interesting? Well, a lot of us use Python, of course. Like we have a whole serving SDK built in Python, and it's really great. Python's amazing for a lot of different reasons, but the problem with Python is that because it's slow, you get in these cases where you have to go rewrite a whole bunch of stuff, and now you're talking to like C++ or Rust or something else to try to get things done. And so Mojo makes it really easy to say, okay, well, for this tokenization logic or for this other thing, I can now push it into Mojo, and Mojo and Python know about each other and work really well together, and so it makes it really simple. The other good thing about this, which I skipped over, is that Mojo runs on the GPU, and so we have a full way to program custom kernels, which a much higher level of abstraction makes it much easier to run things on a GPU, and we're investing in making that better and better every day. So going on, let's talk about the solution, because not everybody wants to invent new models. Turns out there's a lot of common models out there, and obviously we can provide them, but for researchers, you want to know and be able to control things, you want predictability. For AI engineers, you want to be able to build on top of LLMs as a concept. And so this is what we have. We call it the GenAI solution. Why might we care? Well, first of all, there's lots of endpoints out there. Obviously, OpenAI, which may not be as open as you might want. But APIs are great for many things. They're super easy to switch between and go. They're not great for control. And so if you want to do something slightly custom, if you want to run it on your own data center, if you want to run your VPC, you may not want to be sending requests across the open internet, for example. Well, so then if you want to get off of one of these things, you end up having to get into that gigantic bag of complexity that I was talking about before. And so what we do is we say, okay, well, we have this platform that I was talking about before. Let's go build a solution on top of this, which is just one of the applications that's built on top of this, and take advantage of all this fancy technology. And let's see if we can make it simple. So, oops, I don't know what. So the cool thing about this is that because this system that is built on top of is all super easy and simple and consistent, and it actually works, what we can do is we can make the whole experience here really easy. And so this system, it drops into any OpenAI compatible ecosystem, which is very nice. Supports things like PyTorch LLMs, things like Llama and Pixel and other common architectures go super fast. But you also get local to cloud. And so you can run it locally on your laptop, not just on a data center GPU. And so let me show you kind of how this looks. And so this is a end-to-end demo starting from scratch. So this is an Apple M3 laptop. My buddy Tim just put together a simple demo. We're going to download this thing. It's a line. This is a completely fresh install. There's nothing else going on. So he's starting up server. Why did it download that fast? Well, it's because we don't have many gigabytes of random CUDA stuff involved in our packages. This is the benefit of a clean slate thing. Server starts up, says, okay, well, let's start downloading some weights. Let's get the model going. Oh, this is a fresh build. Something I care about, as I've worked on compilers, is I care about compilers that are actually fast. And so this is doing a from-scratch compilation of the entire model without any caching. It takes about 20 seconds. Right, so something like TensorRT can take an hour, depending on what you're doing. It's crazy these days. So if you get it booting up, you go. Okay, now let's switch to another tab and actually give it a try. We can send it a request. Let's see what's funny about Chris Lattner. It says, okay, get things going. And it says, well, there's nothing funny about Chris Lattner except how he looks. So a multimodal model could actually see me, but not for this demo. And so you can see, yes, it actually does know things, and it can actually answer questions, right? But so that's a minute, right? That's a minute to get up and going and running on your laptop. The same install works on a GPU machine in cloud. Like, it's not figure out which Docker container is pre-configured to work in this one different way. It's designed to be easy and actually work, which is really, unfortunately, fairly unique. So when we zoom out and we look at this, we think about this from a number of different ways, because there's so many different use cases for AI. There's different things that folks want to do these days. So with this max serving system, you can bring arbitrary PyTorch models, which is really important for generality. We have a very fancy PyTorch integrated thingy that makes PyTorch go fast, which is cool if you care about that. And as I said before, you can decide to rewrite your model. And if you really care about inference, you care about TCO and cost, this is actually a pretty big deal. Now for us, this isn't just a theoretical thing. We care about, again, we're not using NVIDIA's software stack. And so we care about meeting and beating NVIDIA on their own hardware. And so we compare against things like TRT-LLM and VLM and SGLang and these kinds of things. And so if you want free performance, like having your control of your stack and being able to get that end-to-end control and performance and things like this, it's really powerful. And so if you're interested in performance, then let us know. So this is a quick tour of a whole bunch of stuff. Let me tell you where we are and what we're doing. So we just barely launched our GPU support right before the Christmas break. And so this is very hot off the presses, and there's a whole bunch of stuff coming together. All the stuff I showed you, you can download and use now, by the way. This is all real. And so if you want, you can go build and run models with the Max framework. If you're using A100s, that's where we started. It's available now, and very excited and happy to talk about that. And so we know that A100s for LLM serving are extremely popular, and so we can help. And if you're interested, reach out. Everything is coming together now. It is so exciting for me and the team. We've been working on this thing for years. It turns out that building a replacement for CUDA is actually pretty hard, turns out. And so H100 is coming just in the next few months. We're documenting, cleaning a bunch of the GPU programming APIs. There's this other hardware out there that's also very popular that has some suboptimal software that we're very excited to help with, and so that's coming very soon. And so the next few months, you're going to see a ton of stuff drop from us. So to wrap things up, if you're on A100, you're doing LLMs, you care about performance and features and things like this, please reach out to me or my partner, Tim. If you'd like to join, we have a big open community and forum and a lot of things going on. Please join our discourse or Discord. We have a newsletter, and so if you'd like to keep track of like when H100 drops and things like this, like super happy to talk about this stuff. And oh, by the way, coming back to the earlier point, I believe in open software. And so not everything in Max is open today, but that will be changing. So I don't know how much time we have, but
so I'll let you keep holding the mic. but I'll just add that if you have questions, we have a microphone right there. And so I welcome you to please stand in front of this microphone right here and ask any questions you would like to ask. I see someone getting up. Thank you for being brave. Yeah, I know this. I know the faces in this room. I know you guys have questions, guys and girls. Please.
First off, crazy ambitious. I love it. Like, kudos. I know one of the things I really liked is you said, you can go straight from local to cloud. I don't know, maybe you were kind of teasing that, but have you thought about sort of the Apple Silicon environment and, yeah, specifically Apple Silicon?
Yeah, so we do run, like I showed, natively on the Mac. Currently we run the CPU, so we're not using the GPU features. We have a lot of requests for that. It's just not something we've prioritized. So we can look at that maybe this summer or something. Is there a more specific question?
I was just thinking, yeah, the GPU or even neural engine, if that's something that you think is on your roadmap.
It's not something that's on our committed roadmap right now. We're focused on H100 and things like this because that's, like, people are screaming for this.
Yeah, totally.
But I care a lot about that, like the DevX, the experience there, and so it makes tons of sense. So.
All right, thank you.
Yep.
What's up, Chris? First of all, awesome to see everything come together. Beating VLLM without using CUDA or anything is obviously a big feat for anybody who's tried CUDA at least once. My question is about the PyTorch ecosystem. So I saw that you have Max Serve with PyTorch. Do you expect or hope developers to transition away from PyTorch at some point, or is this strategy to just completely integrate and be able to run any PyTorch model with the Max backend?
Yeah, so great question. This is something we talk about a lot. So right now we've been very focused on inference for a variety of reasons. That's where a lot of the suffering is these days. PyTorch is really pretty great for training. And so we haven't thought about bringing in training APIs and things like this that Modular's doing. We do have a bunch of ambitious people in the community. And so there are people building training frameworks that are like better than JAX and better than PyTorch and things like this. And so the community is exploring that. But I mean, my sentiment is that PyTorch is pretty good. And the things it struggles at are deployment generally. And so, like, if it ain't broke, don't fix it. But there's other people that have other ideas, and I'd love to see the flourishing, and I'd love to see people doing this stuff.
Cool, thanks.
Hi, Chris. My name is Max, so I love the name of your
There you go.
product. And I'm also a former Zoogler, and I know Tim is from Google. So I'm curious, you worked on XLA compiler at Google, right? Like, what Google is doing well in terms of like competing with NVIDIA, and are you planning to support TPU ecosystem, JAX ecosystem, and also Grok, which also has a lot of former Zooglers?
So let me take apart different parts of that. So again, we have people in community that are writing JAX to Max converters, and there's a whole bunch of stuff happening. A lot of what we're building at Modular is directly learned from building and scaling TPUs. So I joined Google in 2017. My starter project was to get TPUs to work. They installed all the hardware in data centers. None of the software worked. And they had ambitions to launch it in cloud. and so XLA technologies like this learned a tremendous amount about it. And so this is why, for example, we work on CPUs. This is why we support dynamic shapes. This is why we support custom operators. This is why we support all this kind of stuff. This is why we have programmability and things like this. And so you can think of some of this as being like, not just XLA, but we learned from Onyx and PyTorch and like many other systems that exist. And so we're trying to do the next generation system. So, yep.
Hi, David Hall. I think there's a lot of new silicon coming into market right now. The biggest challenge that they're facing is the same problem AMD's faced in competing against NVIDIA, and that is getting software that's really usable. What would be your recommendations to new silicon providers and to the hyperscalers that are also bringing fresh silicon to market and using something like this to launch quickly into a larger developer pool?
Well, so the fundamental problem that hardware folks have, regardless of who they are, unless they're NVIDIA, is that they're not competing with NVIDIA software. Right. CUDA is like a huge investment that NVIDIA's made, but that's not really what they're competing with. What they're competing with is the entire world that's writing AI software for NVIDIA, right? Because what CUDA does is, sure, like some of these folks have CUDA compatibility wrappers and things like this, but the kernels written in CUDA are not even portable, performance portable across generations of NVIDIA hardware. We have things like Blackwell coming, right? And so what this means is that we as an industry are on the precipice of having to rewrite everything that matters and tune it for Blackwell. Well, so that's crazy if you think about it, right? So that's going to hold back the entire industry, particularly for hardware innovators. And so what Max and Mojo does is it allows us to write algorithms that are portable by default. And so this means that by investing in writing portable kernels, this means that you can like leverage that investment, which is great for hardware innovators. And so, so this has been part of my passion. I'm like on record for like being very, very, very passionate about this for a really long time. And the times now, the problem we've had is we have to get GPU support out. And the challenge I've held the team to is I want to see us validate the tech platform, not just have a cool thing that doesn't work very well, but have it actually meet and beat NVIDIA. If we can do that, then I am confident that it's good. And if we said, okay, there's an alternative thing that's not as good, then I wouldn't be impressed. So I wouldn't expect anybody else to be. And so we're phase shifting. And so I think you'll hear a lot more from us in like the summer kind of time frame. And I think that there's a lot we can do to help catalyze software on lots of different kinds of hardware.
Thank you so much, Chris. And you know, I'll shout out that we